This is classroom. Okay. Now, look for the third problem. What is the third problem? Calculate all AC parameters for the following circuit. Okay. The circuit is this is what is the circuit, and this is what is transistor 1 and transistor 2, and this is collector, base, emitter, and now this is base, collector and emitter, and this is the output voltage. Okay. For this circuit, asking for all AC parameters. All AC parameters means voltage gain, current gain, input impedance and output impedance. Okay. Let's solve. I told you, is it AC analysis or DC analysis problem? This is surely AC analysis problem because asking for AC parameters. Then we need to write AC circuit. As I told you, maybe for this problem also, if I give you AC circuit, you will understand clearly. Then let me draw AC circuit from this. AC circuit. Right? Now if you observe clearly, just observe here, don't write how I am drawing. If you understand this point, this is what is connected to ground. Why? This is what is connected to power supply. Then the power supply is connected to ground, but for AC analysis, the power supply can be taken as ground because replacing with dynamic resistance of the battery, which is what is 0, or the change in the voltage is 0 with respect to time or with respect to current, what it may be. Therefore, now this is what it is. Now this is what is your input and this is the source. And this is the source Vs, and this is what is the input voltage Vi, and this is Rs. Rs is equal to, let us say, 1 kilo ohm. Right? Now this output, right, this is what is Q1, this output is given to next transistor Q2, right? Therefore now this is what is our transistor. This is your RL, which is 10 kilo ohm, and this is V0. Now this is also connected to ground. Both are AC ground. This is AC ground. This is also AC ground. Only for AC analysis it is connected to ground. And this is what is transistor 2. Now if you ask me, right, this is what is stage 1. This is stage 1. And now this is stage 2. This is what is stage 2. We have 2 stages. Now this is what is our load. RL is equal to 10 kilo ohm. Now this is what your V0. Okay. Now if you ask me with respect to block diagram, this is what is CC amplifier 1. Therefore can I say this is CC amplifier? Why? We are applying input voltage at base because this is what is our collector. This is collector, this is emitter, and this is base. Applying input voltage at base with respect to ground, taking output voltage at emitter, this is what is output voltage. Let me say this is what is output voltage. Let me say this is what is V01, first stage output. This is what is first stage output, which is input to second stage, what it may be. And this is nothing but load for your first stage. Therefore, this is first stage output. Now, applying input voltage at base with respect to ground, taking output voltage at emitter with respect to ground, collector is at ground. For both input and output, collector is common. Therefore, this is what is CC amplifier 1 or CC amplifier stage 1. CC amplifier stage 1. Okay. Now, what about the stage 2? Applying input voltage at base with respect to ground, and taking output voltage at emitter with respect to ground, and collector is at ground. For both input and then output, collector is common. Therefore, this is also CC amplifier stage 2. This is what is CC amplifier stage 2. But remember, the overall name of the circuit, this is nothing but Darlington pair. This is Darlington pair. Darlington pair. Okay. Therefore, if you ask me with respect to block diagram, right, this is what is, right, this is what is stage 1 and the output is connected to stage 2. This is with respect to block diagram, right. Therefore, this is what is CC amplifier, okay, stage 1, and this is CC amplifier stage 2. Output of CC amplifier 1 is input to next stage, and here this is what, and now we are connecting source Vs and then Rs. This is Vs and this is Rs, which is 1 kilo ohm, and this is now connected to load. This is what is our RL, which is 10 kilo ohm. Therefore, now this is what your V0, and this is what is internally, this is what is called as V01, right, and this is what is Vi, right. Therefore, this is what is stage 1 and this is what is stage 2. Now, every stage is associated with input impedance and output impedance, right. Therefore, this is what is having input impedance. Let me call this input impedance as Ri1, and this is having output impedance. Let me call that as R01. Similarly, this is also having input impedance Ri2 second stage, and this is having output impedance R02. Just notation, okay, with respect to stages, stage 1 and then stage 2, right. And let me say this is what is having voltage gain AV1 and current gain AI1. Similarly, this is having voltage gain AV2 and current gain AI2. That is what I am saying, okay. Okay. Therefore, now this is what is our amplifier, but having two stages. Now we need to calculate all AC parameters with respect to load and source. Okay. Take it. Then let's solve one by one. Then you'll understand. Don't think that it is AV1 by AI1. The meaning of this is nothing but we have two parameters, voltage gain and current gain. Okay. Then I can say AND. Okay. Maybe if you ask me to represent with another block diagram, irrespective of all those things, now this is nothing but this is two-stage CC amplifier, or I can say Darlington pair. This is nothing but Darlington pair, and this is output and this is what is the input. Okay. Now this is what is your voltage source, this is your RS, and now this is what is your VS. Okay, and this is your VI. And now this is what is your load. And this is your V0. Then let me say this is what is having input impedance Ri, this is having output impedance R0, and this is having voltage gain AV and current gain AI. That is what we need to calculate. Therefore, for this Darlington pair, we need to calculate input impedance, we need to calculate output impedance, we need to calculate voltage gain, we need to calculate current gain. For the two-stage CC amplifier. Therefore, this is what is the stage. This is what is our two-stage amplifier. Then what is your AV? AV is nothing but AV1 into AV2. What is AI? AI1 into AI2. But don't say that Ri is nothing but Ri1 into Ri2. No, input impedance is not like multiplication. Only gain parameters we can have multiplication. Where we have the relationship between output to input, those parameters only we can multiply. But Ri is only input parameter. R0 is only output parameter. Therefore, we cannot multiply from one stage to another stage. Okay. If this is over, now we can start solving the problems. Now the problem is calculate AV, calculate AI, calculate RI, calculate R0. If I correlate to this, AV is nothing but we should find AV1 first, then AV2 multiply, you will get AV. Calculate AI1, AI2, we will get AI. What is RI? RI is nothing but RI1. What is R0? R02. Therefore, we need to calculate RI1, R02, AV1, AV2, AI1, AI2. Then we can get everything. Okay? Fine. Let's solve one by one. Okay? The first one, current gain. Let's follow the sequence what you know. Current gain, input impedance, voltage gain, and then output impedance. Something like that. Or you can follow anything. Number one, to find AI. Therefore, to find AI. Therefore, we know that, just listen, I'll give you time to write down. We know that AI is equal to AI1 into AI2. AI1 into AI2. Therefore, if you know AI1 and then AI2, then only we can say AI. Therefore, you can say this is what is equation 1. Now, internal. Therefore, to find, now this is to find AI1. Okay. What is AI1 formula? We know, right? Already. Therefore, we know that what is AI1 using general formula, which is nothing but minus HFC divided by 1 plus HOC into RL. right? Therefore, what is AI1? AI1 is equal to minus HFC. Let me convert the CH parameters or your wish. Therefore, that is nothing but 1 plus HFE divided by 1 plus HOE into what is RL? RL is nothing but load resistance for the first stage. For the first stage, what is the load? That is input impedance of second stage. The input impedance of second stage, the effective impedance seen from the input port is the load for your stage 1. Therefore, can I say this is Ri2 second stage input impedance. Therefore, call this as equation 2. Now, if you find Ri2, then only you will find AI1. Okay. Now, to find Ri2, see so many dependencies, but if you follow the methodology, it is fine. Whatever you want, you try to find. Then ultimately, you will get it. Okay. Remember, this is not objective problem. This is subjective problem. Subjective problem means I think GATE 1992-93, right? That time we used to have subjective problems, and this is for 10 marks. But now it is not to solve the problem. I told you this is to understand the theory as well. Okay. After solving everything, after getting everything, we'll see the observation part. Now to find Ri2, we know that what is Ri2? The input impedance of second stage. Input impedance of second stage. That is nothing but this is CC amplifier. Therefore, we know that what is that? HIC plus AI into HRC into RL. That is the formula for CC amplifier. What is HIC? CH parameters. HIE. And what is AI? The current gain of second stage. That is AI2. Let me call this as AI2. And what is HRC? 1. And what is RL? Real load, which is 10K. Therefore, this is what is your RL. You know HIE, you know RL, but we don't know AI2, right? Anyway, we need to find AI2. Therefore, if you know AI2, here also it is done, there also it is done, then Ri2 is done. When Ri2 is done, then AI1 is done. Therefore, indirectly we are calculating AI. Therefore, if you find AI2, I think AI part will be over. Now, you can call this as equation 3. To find AI2, we know that what is current gain again? AI2 is equal to minus HFC, because CC amplifier, right? 1 plus HOC into RL. See, convert into CH parameters, minus into minus, plus 1 plus HFE divided by 1 plus HOE into what is RL? For the second stage, what is RL? 10K, right? That is simply RL. Now, if you substitute 1 plus HFE 51 divided by 1 plus 1 by 40K into 10K. KK will be cancelled. This will already be calculated, which is approximately equal to 40. Therefore, we got to know what is AI2, right? Now, 3 implies this is what is AI2. Okay. Now, 3 implies, right? 3 implies what is Ri2? Ri2 is equal to what is HIE? 1.1K plus AI2 40 into RL 10K. Therefore, it is 401K approximately, to make it simple, 400 kilo ohm. Therefore, we got Ri2. Then immediately AI1. Therefore, 2 implies AI1 is equal to 1 plus HFE 51 divided by 1 plus HOE 1 by 40K into Ri2. Just now we calculated 400 kilo ohm. KK will be cancelled. 400 by 40, which is 10. 1 plus 10, 11. 51 by 11. What is 51 by 11? 11 fours are, calculate, you will get it, right? Calculate that AI1, then substitute that AI1 in equation 1 and you know AI2, then you will get overall gain AI. Okay? Therefore after substitution what you get? 1 implies, what is AI? AI is equal to AI1 into AI2. If I do any silly mistake, you have to correct automatically, okay? You will get approximately 4.6, right? Am I correct? Maybe if you want exact answer, 51 divided by 11. That is 4.63. You can say approximately 4.6. Then if you multiply, you will get, what is AI1? 4.6 into what is AI2? 40. Then you will get approximately 0. 46 into 4. 4 6 are 24. 2. 4 4 are 16 plus 2. 184. Therefore, you are getting AI which is 184. Then after this we will see the second parameter. We calculated only first parameter. Similarly, we need to calculate other parameters. Right? Quickly. See, answer is important, but ultimately the procedure is important. Okay. Sometimes wantedly I'll do silly mistake. You have to catch, but anyway I'll correct it. Okay. Therefore, don't blindly copy. You try to solve on your own and then continue. Okay. Anyway, you find you cannot tell because this is only one-way communication, right? But anyway, just to think about, I will tell the things at the last if there is any mistake. Okay. Over. I'll wait for one more minute. Then you will see the second one, input impedance. But directly, I don't know whether RI1 is calculated. No, I think we can calculate. Okay. Maybe majority of the intermediate values, whatever we need, they are calculated. Done. Okay. Now the second one, to find RI for Darlington pair. Okay. Second one, to find RI. We know that what is RI basically? RI is nothing but first stage amplifier, right? RI is equal to RI1. Therefore, what is RI1? RI1 is equal to HIE plus first stage amplifier gain into HRC into RL. Okay, this is what is the formula. Now, what is this? This is nothing but HIE plus AI1 first stage amplifier gain. HRC is 1. What is RL? For the first stage, what is the load? Second stage input impedance. Therefore, that is nothing but your RI2. I think we already calculated RI2, right? Yes, that is nothing but your 400 kilo ohm. That you can substitute. What is this? 1.1K plus AI1. What is AI1? AI1 is nothing but 4.6 into what is RI2? RI2 is 400 kilo ohm. 400 kilo ohm. Then what is this? It is 4 4 the 16, 4 6 the 24. It is around approximately I can say 1.8 mega ohm. Approximately 1.8 mega ohm. Therefore, this is nothing but our input impedance. this is Ri1. Now this is your Ri, which is 1.8 mega ohm. That is what we are interested, right? I told the reason to go for two stages CC amplifier is nothing but if you have only one stage, just now, if you have only one stage, Ri is nothing but 400k. Now, what is, if you take two stages, what is Ri? 1.8 mega ohm, which is significant for us. That is the reason why the first stage of your op-amp is Darlington pair. That is the reason why people say the input impedance of op-amp is infinity in the order of mega ohm. That you can take it as infinity, irrespective of source resistance, because the source will not have in the order of mega ohm and all. Okay, take it. If that is over, now I can continue to third one. Ultimately, the boxes are important. Okay, anyway, you have, right? That is fine. Now, third one, to find AV. To find voltage gain AV. We know that. What is AV? The overall voltage gain. AV is nothing but the two stages voltage gain, which is AV1 into AV2. Right? You can call this as, maybe how many equations we used, I don't know. Okay, let me say this is equation 4. Then to find AV1, therefore what is AV1? We know that AV1 is equal to, I gave generic formula, which is 1 minus Hi divided by Ri. Now what is Ri? It is Ri1. What is Ri1? Which is nothing but 1.8 mega ohm. Therefore this is 1 minus Hi is nothing but 1.1 kilo ohm divided by 1.8 mega ohm. I can neglect this, right? Then it is approximately equal to 1. Similarly, what is AV2? Similarly, AV2 is equal to 1 minus Hi divided by Ri2. 1 minus Hi is 1.1k, Ri2 is 400 kilo ohm. This also you can neglect. This is approximately equal to 1. 1 into 1, therefore 4 implies what is your overall voltage gain? That is nothing but approximately equal to 1. Your voltage gain is same only, because each stage is giving gain approximately 1, therefore 1 into 1, approximately 1. It will be not of 0.95, 0.94 like that. Single stage gain will be 0.98, but 0.98 into 0.98, it will be less than 0.98, close to 0.95, 0.94. Okay. Therefore, out of all 4 AC parameters, 3 AC parameters are over. Now we need to see the last one, output impedance. Therefore, the output impedance of Darlington pair. Okay. Try to solve. The people who completed this, right? Try to solve the fourth one, at least the output impedance, which is R0. Then what is R0? Actually, R02 is nothing but your R0. Okay. If you find R02, problem is over. Try to solve. I'll give you just 2 minutes to think about it and then solve. Then I'll start to find R0. Done? Did anyone try? Let's see the output impedance. Okay. Fourth one, to find R naught. Right? We know that R naught is nothing but second stage output impedance, R naught 2, right? Therefore, what is R naught 2? We know the formula. What is that? We know that R naught 2, I gave you, right? CC amplifier derived formula. R naught 2 in terms of EH parameters, right? R naught 2 is equal to RS plus HIE divided by 1 plus HFE. This is the formula, right? Then what is RS? The source resistance of your stage 2. What is source resistance of your stage 2? CC amplifier. Stage 1 is source for your stage 2. Then output impedance of stage 1 is nothing but source resistance, right? Therefore, this is nothing but R01 is the source resistance with respect to stage 2 plus HIE divided by 1 plus HFE, right? Then this is what we can call this as equation 5. If you know R01, problem is over. Therefore, to find R01, to find R01, we know that again same. We know that R01 is nothing but output impedance of CC amplifier. Output impedance of CC amplifier, but that is stage 1. Therefore, what is that? RS plus HIE divided by 1 plus HFE. What is RS? Actual source. Okay. Therefore, you can substitute. RS is equal to 1 kilo ohm, HIE 1.1 kilo ohm, 1 plus HFE 51. If you do, it is 2.1 kilo ohm divided by 51. Approximately, you can take it as 2k by 50. You will get around 40 ohm. This is what we solved. We got it. But you may get 41 point something. But you can take it approximately 40 ohm. Then 40 or 41 doesn't matter. Now, 5 implies to find R02. Therefore, 5 implies what is R02? R02 is equal to R01. What is R01? 40 ohm plus HIE 1.1 kilo ohm divided by 1 plus HFE, which is 51. Basically, this is 40 means it is 1140 divided by 51. I can say approximately you'll get less than 20, or I can say approximately 20 point something or 20. Therefore, what is your R02 or your output impedance? This is R0. Therefore, your output impedance R0 is nothing but close to 20 ohm. If you take only one stage, what was your R01, or here what is R01? 40 ohm. Now 40 ohm became 20 ohm, right? If you use two stages, therefore it is half of the output impedance reduction. But remember, 40 is becoming 20 with respect to 10k. With respect to 10k, either 40 or 20, I can say 0 only. Therefore, output side I am not seeing that much advantage. That is the reason why. If you take op amp, the first stage is balanced and paired, but the last stage is still CC amplifier, because that is not reducing your output impedance significantly. It is reducing, but 40 to 20, yes, half only with respect to factor, but the absolute value, if you see 40, 20, I can say 20, 40 also close to 0. Okay, that's why people don't add two stages at the last stage, only one stage at the output stage. Okay, take this. Then let's see observations. Okay, problem is over. Now we need to have observations. Fine. Is this over? Okay, now let's have observations. Write down observations. See, your voltage gain is not improved. Your input impedance is improved significantly, not even output impedance also. Okay. If you see the observations, right? Therefore, tell me what your voltage gain we got, that is close to 1, right? And what is current gain we got, that is close to 184, right? And what is your input impedance we got, Ri we got 1.8 mega ohm. And what is R0? We got R0 20 ohm, right? This is what your Diode and pair. Okay, write these values, but don't remember these values. These values are true only when load is 10k and source is 1k. If source resistance changes, load changes, these values will change. Maybe voltage gain will be approximately 1, but the remaining values will be changing. Okay, but you can take with respect to some reference, the reference with load of 10k and the source of 1k. Okay, then what is your observation? Therefore, it is what? Having very high input impedance, very low output impedance. Therefore, it is providing very good impedance matching for voltage amplification, but voltage gain is 1. Whatever observations we had seen in the case of CC amplifier, I can say same observation in the case of Diode and pair. Only one thing is your input impedance is further improved from single stage CC amplifier. Okay, write down Diode and pair input impedance, Diode and pair input impedance is further improved. When I say improved, whatever you want, you got it for voltage amplification. Okay, which is nothing but high input impedance. See, Diode and pair input impedance is further improved. Diode and pair input impedance is further improved from CC amplifier, is further improved from CC amplifier, is further improved from CC amplifier for voltage amplification, and output impedance is decreased. Output impedance is decreased, but not significantly with respect to load of 10k, but not significantly with respect to load of 10k. Therefore the first stage of op amp is Darlington pair. Therefore, the first stage of op amp is Darlington pair, and the last stage of op amp is simply CC amplifier. The last stage of amplifier is simply CC amplifier. Let me stop now, then we will continue in the next session. Thank you.